Hi everyone, welcome back to the channel. In today's video, we are diving into the world of statistics, exploring mean, trim mean, and weighted mean. So not just looking at the basic level, but from an advanced data science perspective. So we'll look into the mathematical definition, the real world use case, and I will try to show you how to implement them using Python. So let's first start with the arithmetic mean or simple mean. So it is the most common measure of central tendency. So definition for this, the mean of a data set is defined as, so it is always, it's represented by the bar, that is means it is the mean of a sample from a population. If it is in uppercase, then it means it is a mean of a population. So in this case is a mean of a sample. And the how to calculate mean, just take the summation of all the data points. So this is the summation symbol, I1 to n, and divide by number of data points. So here xi are the data points, n is the number of data points. So this gives us the central value, assuming equal weight for each observation. So when to use this mean? So you can use the arithmetic mean when your data is symmetrically distributed. You have no significant outliers and each data point has equal importance. So to implement this using Python, let's first import the NumPy library as NP. These are considered as our data points. And to calculate mean, we just np dot mean and put it up parenthesis. And let's store this into mean variable. And we can calculate. So this is the mean for this 6 data point, 14.83. Now, this one important thing is the, or I can say the pitfall of this arithmetic mean is a sensitive to outliers. So a single extreme value can skew the result drastically. And as a solution for that, we have something called trimmed mean. So let's bring on to the trimmed mean, a robust alternative to the arithmetic mean, also called as truncated mean. So it excludes a fixed percentage of lowest and highest value before calculating the average. So let's say we trim X percentage from both sides if we sort the database. And the formula for trim mean is this. So in this, k equals to an are the value sorted. So use trim means when your data contains the outlier. You want to reduce variance without completely ignoring the data sheet. And to calculate the trim mean using Python, you can use the SciPy. Let me import the library. And from SciPy, import stats. This is our data set. We have two outlier, 400 and 300. And let's put it into trimmed mean variable. Stats.trimmed mean data and proportion to cut equals to, let's say, 0.2. It's trim mean data proportion to cut. Yeah. And let me run this mean and trim mean or mean of the data. Okay, put into print regular mean equals to this. All right. As you can see, there's a huge difference between calculating the normal mean and the truncated mean. The last one we have the weighted mean. So the weighted mean, which is generalization of the arithmetic mean, where each value contribute differently to a final average. So the definition for weighted mean is this, where W represent the weights and X are the normal values, and we divide by the weights. So when to use the weighted mean? So you can use this weighted mean when some observations are more important than others, and you are aggregating text scores, rating, or a group data. So let's take an example here again for weighted mean. So we have these values, and to calculate W mean equals to, we'll take the average from NumPy and put the values. These are our values, and to define the weight equals to weights, and this will print the weighted mean. So what we mean by here the weights is the 70 value contribute multiply by 0.2, and means 20%, this contributes 30%, and this contributes 50% of the values. And the real world examples, say let's say you are calculating a student's final grade, where quiz are generally like say 20%, midterm maybe the 30%, and final exam contributes to 50%. So that's how you provide the weight with respect to the values and calculate the weighted mean. The last is the just summarization of what we discussed. So we discussed the arithmetic mean, trimmed mean, and weighted mean. So use case, use arithmetic mean when there is symmetry in the data. Trimmed mean when there is data is with outlier, and weighted mean when you want to prioritize certain values. Which means is sensitive to outlier. So symmetric mean yes, and prioritization is also sensitive to outlier, but in the case of thin mean, it has very less sensitivity to outliers. And need weights for the weighted mean, you will definitely need the weights. So yeah, so now you know how to work with the arithmetic mean, thin mean, and the weighted mean, both theoretically and in the code. So if you're doing robust statistic, machine learning, or just trying to interpret your data better, these tools will help you. So if you found this video helpful, don't forget to like. Thank you. I will see you in the next one.